All right, 7th grade, you guys are getting good at adding integers and rational numbers and using those integer rules. So we are going to move on to subtracting integers. So let me get my pen. Our learning goal for today is I can subtract using integer rules. So maybe your learner's question would be something like, what are the rules for subtracting integers? Maybe how is it different, or how are the rules different than adding? And then go ahead and pause the video and take a second to work on our 2 bell work problems here. Bell work 1 and bell work 2, review of percents from last topic. So the first thing we're going to look at is how to write equivalent, so meaning has the same value, subtraction and addition expressions for each number line model. So when we're dealing with these number lines, what I want you to notice is that we're always starting at 0. Oh, why does it keep doing that? Sorry. Okay, so we're starting at 0, and I can see that from 0, I'm moving left 2 units, and I land here at this blue dot at -2. So that's the first number in my expression. From -2, I am moving 1, 2, 3, 4, 5 more units in the negative direction. So I'm going to say that's -5. And where I landed was at -7. So I started at 0 and I went -2, and then I went in the negative direction 5 more units, and I ended at -7. So from this model, we could say that -2 minus 5 equals -7. Let's look at our second model. Again, we're going to start at 0. So I find 0 and I see that I'm moving in the positive direction. So I'm going +6. From here then, I'm going left or in the negative direction, and now I'm moving 1, 2, 3, 4, 5, 6, 7 units. So I went 7 in the negative direction, and I ended at -1. So we could say that 6 minus 7 equals -1. So now let's look at how I can write equivalent subtraction and addition expressions for these number lines. So I've written a subtraction expression for each, but let's look at what this would look like as an addition problem. I'm still starting at 0, and I'm moving -2 units. From here, I'm adding another -5. So instead of saying -5, I could also say plus -5. And I'm still going to end at -7. Over here on our second model, I'm starting at 0 and I'm moving right 6 units. So that's a +6. But instead of saying -7, I could say that I'm adding to 6 a -7. So I could say plus -7. And I still end up at -1 at the end of that. So 2 different ways of saying the same thing. Now remember, I'm only using these parentheses so that I don't double stack a sign. I don't want to put plus and negative right next to each other, so I use parentheses to separate those signs. This doesn't mean multiplication because I have the plus sign next to it. It just means that I'm adding what's inside of the parentheses. So let's check out a vertical number line similar to what you'd see on a thermometer, and let's figure out which expressions the number line model represents. So again, as I look here, I'm going to start at 0. And I can see from 0, I'm going up 2 units, or positive 2. From 2, now I'm moving down 1, 2, 3, 4 units. So I could say that's a minus 4, or I could say 2 plus negative 4. Both of those are saying the exact same thing. And what I see is that I'm ending at negative 2. So 2 minus 4 equals negative 2, and 2 plus negative 4 equals negative 2. So in fact, this is our definition of subtraction. Subtraction literally means I'm adding the opposite, or I'm adding the negative. So let's look at a word problem. Between 6 a.m. and noon, the temperature rose from 0 degrees Fahrenheit to 8 degrees Fahrenheit. By 5 p.m., the temperature had dropped by 10 degrees Fahrenheit. By 8 p.m., the temperature dropped another 5 degrees Fahrenheit. Write and simplify a subtraction expression for the temperature at 5 o'clock and at 8 o'clock. Model each expression on the thermometer. So let's look first at writing a subtraction expression for the temperature at 5. So we know that at 6 a.m., from 6 a.m. to noon, the temperature rose from 0 to 8 degrees Fahrenheit. So I'm really starting here at 8. I'm going to start at 0, and I'm going to go up to 8 here. And then from here, the temperature dropped 10 degrees. So from positive 8, I'm going to now go down, or negative 10 degrees. So that brings me down here to negative 2. On the right side, oops. Let's see, on the right side of our thermometer, let's write in green, and now let's write about the temperature at 8 p.m. So at 8 p.m., if we start again at 0, the temperature at 5 p.m. we said was negative 2. So I'm going to go down 2 degrees from 0, and I end up here at negative 2. And then I know that the temperature is going to drop another 5 degrees. So from negative 2, I need to go down 1, 2, 3, 4, 5, which is going to bring me to negative 7. All right, let's keep practicing this idea with another word problem. The map shows the highest temperature ever recorded in the United States. The lowest temperature ever recorded in the United States was 214 degrees lower than this temperature. So here's this temperature. This is the highest temperature ever recorded. The lowest temperature is going to be 214 degrees lower than this, lower than 134. So we're going to write and simplify a subtraction expression to represent the lowest temperature ever recorded in the United States. So first, I'm starting at my very highest temperature. So I'm going to start at 134 degrees. And now it's going to go lower 214 degrees. So I'm doing 134 minus 214. So this is really like adding the opposite. So if it's easier for you to think of this as adding a negative 214, since we have such large numbers and we can't probably just do this in our head right off the bat, let's think through our integer rules. Now that I've changed this into addition, Now I can use my integer rules, which says if I'm adding numbers with different signs, like these, a negative and a positive, I'm not actually going to add them. Since I have different signs, I'm going to find the difference or subtract. So I can subtract 214 minus 134, and then my larger number takes the sign. Since 214 is larger than 134 and it's negative, my answer is going to be negative. So let's find the difference here. 4 minus 4 is 0. I'm going to borrow 1 from the 2 to make this 11. 11 minus 3 is 8. So this is a difference of 80 degrees, and it's going to be negative. So the very lowest temperature ever recorded in the United States is negative 80 degrees Fahrenheit. And I hope to never experience that temperature. That sounds terrible. So subtracting a negative is really the same as adding a positive. And all of this sounds very backwards at first, but I'm going to teach you some tricks to help you keep it sorted out. So we really have 3 rules that we have talked about so far. We've talked about when we're adding, I can add 2 numbers that have the same sign, 2 positives or 2 negatives. And as long as I have the same sign, I just add the numbers and keep that sign. So if I add 2 negatives, my answer is negative. If I add 2 positives, my answer is positive. If I'm adding numbers with different signs, like we just did up here with our temperature problem, then I'm adding different signs. I'm going to find the difference. I'm going to subtract these numbers, and my larger number takes the sign. So my bigger number is negative, so my answer is negative. Now today, our new rule we're looking at is subtracting negatives. So what we need to know is that subtracting a negative is the same as adding a positive. And here's what that looks like. On this example right here, negative 4 minus negative 3. Anytime I am subtracting negative numbers, I would always change it back to addition. I'm going to use a rule called same, change, change. And what that means is I'm going to keep the first number the same, and then I'm going to change the next 2 signs that I come to. So for this example, I'm going to keep negative 4 the same. It's going to stay negative. But the next 2 signs that I see, I'm going to change. So I'm going to change this minus to a plus, and I'm going to change this negative to a positive. So now I have negative 4 plus 3. So now I'm back to my addition rules. So if I always change my subtraction problems back to addition, then I just need to remember those 2 subtraction rules. So for this one, I'm adding numbers with different signs, so I find the difference. 4 minus 3 is 1, and my larger number takes the sign. 4 is larger than 3, and it's negative, so my answer is negative. If you want to test it out on a number line, you can do that. Or remember, we also drew pictures for these. So when I say negative 4, I literally have 4 negatives, and a positive 3 means I have 3 positives. Well, now I can cross out pairs because a negative and a positive will cancel. And what I'm left with is 1 negative, so it's negative 1. So if you want to draw your pictures to help you practice applying these rules and double check your work, I think that's a great idea. All right, let's try on the second one here. If 1 minus negative 6. So I'm going to do same, change, change. I'm going to keep 1 the same, which means I'm going to keep its sign positive, and I'm going to change the next 2 signs I see. So they were negatives, now they're positives. So now I have 1 plus 6, which is 7. That's easy because same signs keep the sign. All right, let's continue these next couple examples in the second half of the video. You can try these 4 on your own and then check your work in the second video.